Hello, geometry. Today we're going to do 8.4 rhombuses, squares, and rectangles. These are special type of quadrilaterals, and I know for sure you recognize two of them, and some of you might know what a third one is, which is a rhombus. But let's go over what are these, and by definition, what do they represent? Okay, first off, let's just talk about any quadrilateral. Any quadrilateral, let me fix this camera a bit. Any quadrilateral is just a four-sided polygon. So it could just look like, that's not a polygon. It could look like something like that. It could look something like that. So a quadrilateral is a four-sided polygon. So we need special names for special types of polygons. So the first one we're going to talk about is a rectangle. Everyone knows what a rectangle looks like. But by definition, all the angles of rectangles are 90 degrees. So what's the word that we talk about a force, or what's the word we talk about a shape that has all the angles being equal? The word you're thinking of is equiangular. So again, equiangular. So a rectangle, and let me call this rectangle. L-E, I think. A rectangle is a equiangular quadrilateral. Okay. So a rectangle is by definition an equiangular quadrilateral. Now we're going to talk about a rhombus. Now a rhombus, all the sides are equal. All four sides are equal. Remember in a parallelogram, the opposite sides have to be equal? This is a rhombus, and a rhombus, all four sides are equal. So that's rhombus. So a rhombus, what is all sides being equal? What do we call that type of shape? That's equilateral. So that's equilateral. So a rhombus is an equilateral quadrilateral. Equilateral, I think it's, I imagine Greek base. Equal, lateral sides. Quad, four lateral sides. So equal side, four side. That's what it breaks down to. All right, and everyone should know this shape. What happens when all the sides and all the angles are congruent? So all the angles and all the sides are congruent. Well, that simply is a square. And what we call that is when there's something's both equiangular and equilateral, we call that a regular polygon. This is a regular polygon. In this case, this is a regular quadrilateral. Okay? And I should mention all of these, because this adds up to 180, or the opposite sides are equal. You could tell that all of these are parallelograms. So everything here is a parallelogram. And we could use the reasons from 8.2 and 8.3 to prove it, but you just need to know that they are parallelograms for a fact. All right, so here's your first type of question. It's going to be kind of like this always, sometimes, never. Maybe it'll be a true, false, simply type of question. So in rhombus QRST, now let's just talk about how do you draw something. When it says QRST, when you draw it, it goes QRST. So you just have to go clockwise. QRST. Technically, if you go counterclockwise, it doesn't change. But know that QRST should be in that order when you say QRST, like you're going in one line, okay? So when it asks you to draw the rhombus QRST, you draw it like that. Now, remember what we talked about. A rhombus, we know for a fact, all the sides are equal, okay? We also know this is a parallelogram. So for a fact, the opposite angles are equal, and this opposite angle is equal. Okay? Now, let's ask the first question. In this rhombus QRST, do we know for a fact angle Q is congruent to angle S? Is that always true, sometimes true, or never true? Okay, by definition, Q and S, this is a parallelogram. Rhombuses are parallelograms, rectangles are parallelograms, and squares are parallelograms. So you need to refer back to even your parallelogram facts. You know by definition, Q and S are opposite angles. And in any parallelogram, the opposite angles are congruent. So since these two opposite angles are congruent, that makes Q and S always true. So the answer for this one is always true. Now, what I drew here is what we know for a fact every time with a rhombus, okay? Which includes some other facts with parallelograms. Let's check the next question. Do we know for a fact Q and R are congruent angles? Well, Q and R are not by always congruent angles. But there's a way to draw a rhombus where Q and R are equal. What way can you draw a rhombus where Q and R are equal? If you're thinking about a square, that is the correct answer. Remember, the only thing that defines a rhombus, Q, R, S, T, the only thing that defines a rhombus is that it's four-sided and all the sides are equal. So I'm sure you've talked about this or heard of this before. Every square is a rectangle. That's also true of rhombuses. Every square is a rhombus. But not every rhombus is a square. So there's some rhombuses, rhombus I guess, that Q and R are not equal. While there are some rhombuses, particularly squares, where Q and R are equal. So because sometimes it isn't and sometimes it is, your answer for this case, when Q is congruent to R, is sometimes. Okay? So Q equaling R is sometimes. Because sometimes there's a rhombus that's like normal, or I guess just a rhombus would be more descriptive, that they're not equal, all the angles are equal. They're not equiangular. But a square, it happens to also be a rhombus. So you're allowed to say, yeah, QR, this is a rhombus, even though more descriptively it's a square. This is a rhombus, and this would count for it being equal. Let's do one more question. Does Q plus R equal 180? Well, as I said before, rhombuses and squares and rectangles are parallelograms. So half of the angles on the same side are, what is that word that adds up to 180? Supplementary. So Q plus R adds up to 180. Q plus R always adds up to 180 because rhombuses are always parallelograms. So this one is a always. All right. And let's do one more. Let's do line QR is congruent to line QT. Again, we're talking about a rhombus here. By definition, a rhombus, all the sides are equal. It's equilateral. So by definition, we know for a fact, the fact that I just said the word, this is a rhombus, you know for the fact all the sides are equal. And because all the sides are equal, QR is congruent to QT. So this is always true. Okay? So QR is congruent to QT is always true. For a rhombus, okay? For a rhombus. So this next part, I'm going to post also on the Google Classroom a picture of the summary of these theorems. and I'm just going to talk about them right now. But these would be in the book Theorem 811, 812, 813 on page 529. But let me just talk about this. All right, so we have a parallelogram. And I'm going to tell you it's a parallelogram because we can see they're parallel on both opposite sides are parallel. If you have diagonals like this, so diagonal lines like this, in a parallelogram, and you know it's a right angle, at that moment, as you see, there's a right angle in the inside of these four things. From that moment, you know it's a rhombus. Okay? So rhombuses, the diagonals are, what type of intersection forms a 90-degree angle? Good, if you remember, the word is perpendicular. Perpendicular. So if the angles here are perpendicular, the inside angle is very particular, then it's a rhombus. Okay? And again, I'm sending you the picture of literally what it says in the book, if you want to look at that too. That'll be like the typed out notes. Okay? This video is just to help explain what it's saying. All right, next one. Another parallelogram with another diagonals. It's a parallelogram, so let me just show their parallel. Okay, if you know it's a parallelogram, and if you see that these two angles are bisected, these two angles, let me redraw my line a little bit. These two angles are bisected. These two angles are bisected. And these two angles are bisected. So another way to think about it, all of the corners are bisected. That means that this is automatically also a rhombus. So the corners are bisected or cut in half. These right here are rhombuses. Or rhombi. I still have to figure out what the plural is. But if you see all the angles are being bisected, by definition, that is a rhombus. Okay? By definition, that is a rhombus. I can see someone asking the question, does that happen in rectangles? The answer would be sometimes. If that rectangle was a square, then yeah, that would happen. But does it happen naturally in just rectangles, okay? And talking about rectangles, another set of diagonals. I guess you could call this like the diagonal theorems if you want to, or something like that to refer to it. If you know all these pieces are cut exactly like this, so not only they're bisected, that's by definition in a parallelogram, this piece would equal this piece, and then this piece would equal this piece. But you know that these two pieces are also equal to these two pieces. So all four halves of these diagonals, all four pieces, are equal. If you know that, then you know by fact it's a rectangle. Okay? If you know that as a fact, you know that the whole parallelogram is a rectangle. So you need to know it's a parallelogram, and you need to know all four pieces are cut in half. So this is kind of going back to a previous time where we had to know a lot of qualities. So this is why I think this section is a little tough, because it's, again, going back to a bunch of qualities, a little less math stuff and more definitions and descriptions. All right, so this, what I'm doing right now, it's going to correlate to the homework on your page, which is, and let me just pull up the homework, numbers 19 to 24. Okay, so 19 to 24. This is how it correlates. So I think these questions are different. I got them from something else. If not, hey, that helps you out. All right, first let's talk about the first one. Now the question for that section from 19 to 24 is asking you for each quadrilateral, and the ones we're going to talk about are parallelograms, rhombuses, rectangles, and squares. Tell me if it's true or false if the first question asks if they're equilateral. Well, a parallelogram doesn't necessarily have to be equilateral. It's not by definition equilateral. We know the opposites are equal, but not all four sides are equal. So I'm going to say that's false. The parallelogram doesn't always have to be equilateral. Rhombus, by definition, is always equilateral. Literally, that's what makes it a rhombus, because the sides are equal. Rectangle? No, not necessarily. Actually, if you just think of a regular rectangle, that's never true, right? The opposites are equal, but the sides are different. But the angles are equal, right? But the opposites are the same. In a square, it's all true, right? Because the opposite sides and all the sides have to be equal. So the first question here, which is these four quadrilaterals equilateral for a parallelogram? That's not always true. A rhombus? That is always true. A rectangle? That is not always true. A square? That is always true. So these type of questions are talking about the concepts and the understanding of it. I'll make sure to open a Zoom session to help answer these questions. All right, are diagonals congruent? All right, so diagonals. So when I say diagonals, I'm talking about like when you have your shape, these lines in the middle. Okay, are diagonals congruent? Now, I know for a fact in a parallelogram, let me draw one, like this. The two halves are equal to each other, but not necessarily both lines are equal to each other. So for this one, for a parallelogram, not necessarily. For a rhombus, I know the inside angles are perpendicular, and I know the outside angles are bisected, but nothing about the side, like the actual length of the lines. For a rectangle, though, remember, a rectangle, the diagonals are all cut in exactly the same size. So let's say if this was 3, this would also be 3. This would also be 3. This would also be 3. So since all the pieces are the same size, we know all the diagonal, the whole thing is the same size. So this one would be true. And in a square, since a rectangle can do it, a square can do it also. So that becomes true. So in the question, are diagonals congruent? Parallelograms and rhombuses? No. Rectangles and squares? Yes. Next one. Can it have an obtuse angle? Can it have an obtuse angle? So a parallelogram can has an obtuse angle. If you want to see how it looks, it would look like something like this, where this one and this one are obtuse angles. So a parallelogram could have an obtuse angle. Rhombuses can also have obtuse angles. Now, rectangle, by definition, the rectangle, all the angles are equal. And when all the angles are equal in a quadrilateral, that's 90 degrees. So by definition, all the angles are 90 degrees. So it's impossible for a rectangle to have an obtuse angle, because that contradicts the definition of having all right angles. Same thing with square. Because it contradicts the rectangle's definition, it contradicts the square's definition. Because it has to be right angles. It cannot be obtuse angles. So when the question is, can it have an obtuse angle? Parallelogram and rhombuses, yes. Rectangles and squares, no. All right, last one. No acute angles. No acute angles. So it doesn't have any acute angles at all. Let's go. For a parallelogram, there's no acute angles. Well, for a fact we just said these are obtuse, that would leave these to have to be acute. So, by definition, a parallelogram will end up having a acute angle. So this is not true. Does it have no acute angles? Yes, it does have acute angles, so this is false. Rhombus, same reason. The same way that it could have an obtuse angle, that would force the other angle to be acute, so this cannot be. A rectangle by definition are all right angles. So since they're all right angles, it cannot have any acute angles. So when it asks, does it have no acute angles? By definition, rectangle does not have any acute angles. Same thing with square, the same reasoning as rectangles. All right. I just hit the 20-minute mark. I'll put a zoom to help out. This is all concept based, but you guys can handle it. All right. If not, though, don't be afraid to ask questions.